Uh, First, keep your video on.
Okay.
If we have any problem or any issue, then I will tell you to video off. Otherwise, keep on, because in during your lecture the video is coming. So that is okay, sir. That will be better, sir.
No, but the bandwidth issue is there with my house, so I might have to.
Sir, if it will be problem, then I will inform, sir.
Okay.
If it will be problem. Otherwise.
Okay.
Pratik, can we start? Pratik? 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 Okay. On sir. So, good morning, sir. And I would like to request Ms. Sonesa Rathan. He is the faculty member in the Department of Civil Engineering, to introduce Dr. B. Krishna Prapurna, who is the associate professor at IIT Tirupati. So it's hand over to Ms. Sonesa. Please continue.
Good afternoon, all. I would like to welcome Dr. B. Krishna Prapurna, Dr. B. Krishna Prapurna, the Associate Professor in Department of Civil Engineering at IIT Tirupati in India. IIT Tirupati, India. He obtained the doctoral and Masters of Science degree in Civil Engineering and Environmental Engineering from Arizona State University, USA. His research and teaching experience include transportation pavement materials, design, maintenance, and rehabilitation, highway noise evolution, and modeling sustainable and smart infrastructures. He is the lead researcher of Advanced Pavement Systems Research Cluster at IIT Tirupati. He is also associated with various international societies such as US-based National Academics of Engineering, American Society of Testing and Materials, and Recycled Asphalt Pavement Foundations, etc. He serves as the editorial board member of many journals, that too ACE, ASTM, Springer, with 100+ papers on reputed journals. He is also a lifetime member and executive fellow of International Road Federation. Now I would request Sir to give a presentation on automation in pavement management systems.
Welcome, sir. Another dear participant, I want to inform you that due to the 12 noon, that is the lunch time basically. So we have kept introduction of Dr. Krishna Prapurna very shortly actually. But as per his research concern, he has done many works that if I will describe, then it will take, I think, 30 minutes or 45 minutes. So sorry, sir, for keeping your introduction very less.
No,
so, Professor Krishna Prapurna, sir.
Thank
Welcome,
you,
sir. Welcome to ARC 2021. Thank you, sir.
Thank you
Please
very
continue,
much.
sir.
Yeah,
Sir, before that, just address our participants a few words, sir. Then you start, sir. Okay.
Yeah. So thank you very much, Sujit and Anvesha. This is probably the second time I'm doing for IGIT. I'm very happy for this event also, because this is something that's really a hot topic, and automation is one of the things that we really have to do to keep our records intact for the next few years, probably few decades to come, and also help the generations to benefit from the data that we are storing. Because one of the things that we really have to do is to have excellent database kept with us, so others can also benefit from this. They can learn from us, we learn from them. It's a mutual understanding between the industry, academia, and many other stakeholders. But very nice, very kind of you, Sujit, for inviting me. Thank you very much. So I think if I may be permitted, I will start the presentation. Okay.
You may continue, sir.
Sure. Just trying to share. Yeah. So you're able to see this, I hope.
Yes,
so,
sir.
Right?
Okay, sir. Okay, it's okay.
Yeah. Okay. Good. So one of the things that I thought we should talk about today, because the event, the workshop by itself is on automation and robotics in construction industry. And if you look at this, it's a very multidimensional team. When we talk about automation and robotics, that's where the merger of several departments comes into picture. It could be civil engineering, it could be mechanical engineering folks, and then the industrial engineering, and also computer scientists coming into picture, electrical engineers. So it's a multidimensional team that should work on this automation and robotics. That's something that we really have to acknowledge, the technology, okay, and the sophistication that is around. Now, if you look at what we will be speaking today is on pavement construction and asset management. There are two different aspects I thought we should share with you. And there are a few toolkits that we have developed from scratch, and that really helps us understand that, yes, we have to really gear up ourselves to use the database that we have coming from the industry. Okay, and that's where I always keep saying, the model, the academia industry model, that has to really fructify, and that will happen when we actually work for the industry. So it should be a client-based approach. So what I thought we will have is two important modules. One is the LCA toolkit that we have developed from scratch, and we will share with you what we have done, and also the pavement asset management, because most of the things that we have in pavement asset management research area are now automated. So before that, I thought I should share with you some ideas about what our visions are and what we have been doing with our group. Right, sustainable pavement technologies. When I say sustainable, that's more on the smarter side, and which also helps keep up the ecosystem in a very sustainable and green infrastructure. That comes up as the key word, right? So we are looking at several pillars, and if you look at what we are showing you here, one of the things definitely is the key infrastructure, and that goes without saying that if you really have to provide good infrastructure for the citizens, you have to provide them good quality of life, right? And when we talk about that, then under the larger umbrella, we say that it should be very clean, and it also has to be a sustainable environment. And if you people are familiar, there are several smart solutions, and we need to be promoting those in terms of achieving our goals, sustainable development goals. For example, you're all familiar with e-surveys, and there is also this waste management, energy, water nexus. These are the energy, food nexus. All those things are there together as a group, right? And one of the other things is the transportation, where there are two important aspects. One is the mobility, that's the transportation traffic side. The other is the infrastructure or the material side, right? So there are two important aspects. So what this presentation will talk only about the roadway asset management and the construction aspect. So we call that green and smart. So this presentation will only concentrate on this, not on the other things. So I just thought I should share with you our group. So if you have time, please visit our website. We have a vibrant group. We have more than about 10-15 students now working together on several advanced pavement systems research areas. Okay, you can see our lab is well suited to do fundamental research, where we can do binder testing, aggregates, and also the mixtures, advanced mixtures. We are coming up with several state-of-the-art products. Okay, when you look at the state-of-the-art advanced research, we have some of the best equipment in the country right now, and we are able to do all kinds of experiments, may it be tensile, compressive, fracture, fatigue, many other things. Okay, we also have come up with several research areas that you can see here. Okay, one of the things that you are able to see here is the vehicle pavement interaction that we are currently working with NHAI, National Highways Authority of India. And it's a larger project. It's a pan-India project that we are trying to do. We are also collaborating with several other academic institutions. Then the other one is the environmental concern. That's something that that's very close to my heart, because we have been working on this Vermix asphalt. We've also been developing some good products, which also will encompass rubberized asphalt, which I show you here, the asphalt rubber. That's something that I've been familiar with over the last 15-16 years now. The other thing that the two important aspects is, one is the pervious concrete. We started all the way at IIT Kharagpur when I was there between 13 and 17. So we have now come up with some new generation pervious concrete products that we can show you a few glimpses of those, but you can actually go and look at our own publications where we have more details on these. The other thing that I thought we should share with you, and what I'll be presenting more within this presentation, is about pavement asset management. Right, we have come up with 5 or 6 modules using the deep learning techniques and also image processing. So they're all automated now. So we have been working very closely with the Andhra Pradesh state, Road Development Corporation, APRDC. So that's where I told you in the beginning, we need to be having that academic roadway agency model really coming into picture, because that's where we can always familiarize ourselves with what the industry really wants from the academia, and academia also learns many things from the industry in terms of solving their problems and burning issues, right? So you can see some of the good pictures from our own products that we have placed on campus IIT Tirupati. So in fact, we have made a small presentation last year in one of the other events on pervious concrete. So now coming to the conferences that IIT Tirupati is hosting, one that's coming up in 2024 is rubberized asphalt rubber. It's on the new products using rubber-based binders, asphalt binders. Okay, that will be hosted by us. IIT Tirupati will host it. Then one of the other things is the smart cities, international conference on smart cities. That will also be in India in 2023. One that's coming up immediately very soon in May this year, May 28, 29, 30. I'll share with you the next slide where you can see there are at least 30 countries participating across the spectrum. Okay, so what we are doing right now is to have good collaboration with the industry. We have APRDC, we also have CRRI folks with us, many other centers collaborating with us. Okay, so this is what I was saying. Please try to visit this website. It was supposed to be held last year, October. Due to COVID, we have actually postponed it, and it's a virtual conference. So please feel free to register. We have an early bird right now going on. You can always register for the conference. It's on sustainable pavement technologies, which will involve resource conservation, and then sustainability aspect, okay, recyclability of rubber, and many other aspects. So IIT Tirupati is the host with International Conference on Resource Sustainability. So you can see here there are several co-sponsors for the event. ASTM, Forum of European Highway Research Laboratory, CRI is also hosting, co-sponsoring. Then we have other entities such as the TRB, Transportation Research Board, and also several other people. NHAI is there, who is also part of this team. Okay, so please visit this website and then get familiarized with the conference. Okay, now let's start the actual presentation. Okay, one thing maybe I should mention this before I actually move back. So you see, this conference will be actually inaugurated by the Honorable Minister. That's what we have tentatively talked to Shri Nitin Gadkari ji. So we have got the news that yes, he'll be in the inaugural session. So it will be a very nice event. Please, it's a international event hosted by India on the first of its kind conference on sustainable pavement technologies. Please visit the website, get familiarized. Okay, so now let's go to the actual thing that we thought we would present today. One is the LCA toolkit life cycle assessment. I just thought I should share with you because we have done some work on pervious concrete. We've been placing test sections. We've been developing new generation products. And one of the things that comes up as a question is, how long will these sections last, right? And can we reuse it? And how much of energy has been consumed? And how can we compare this product with the other products that are there in the field? And how much of emissions, and is it a green material? So these are the questions that we have had. And so we actually developed a toolkit from scratch. So if you really have to buy software, that will really be an expensive one. So instead of that, if you're able to develop your own toolkit, it doesn't have to be only for the pervious concrete or some other product. It's a product toolkit. So you can use it for buildings also. right? So it's a published document, and I'll share with you more details on that. And we're coming up with new materials, so that's also the important thing. So here, because event actually talks about the automation, so we will share with you what we did with simple MS Excel toolkit, right? You're able to automate your own ideas, generate the outcomes in the form of assessment tools or metrics, assessors, right? So what we did, we created a framework for energy consumption and carbon footprint of building materials and infrastructure. That's something as a generic thing. If you look at what we have here, right, there are several phases to this. One definitely is the material extraction. That is something important that we have to understand. And then there is this processing that we undergo. There could be some pre-processing techniques that we will have to take up. For example, if it's a rubber material, you will have to make sure that it's usable, right? And then we come to the product development stage. So you basically invest energy, right, in terms of fuel or temperature. So those are some of the things that are the input parameters, and the output is how does the product function. So is there an emission that could be comparable with the standardized product? That's what we should be looking at, right? And questions are always there. Can we reuse this product even after it has served its entire design life? So that's the end of life process that we look at, right? And most of the products that we have in the market right now, they're looking at not just this, but also after it has served its design life. Can we reuse? That's where the recyclability aspect comes into picture, right? So will it really cause some waste and pollute the environment, or will it be not detrimental? So you need to be very careful there. So when you come up with a product, we should make sure that we also talk about the life cycle, right? Okay, so it's basically a structured framework that we created, and we were able to quantify. So that's something important. We were able to quantify in terms of numbers, so you could compare between the products, right? So if you look at these life cycle phases, there are 4 important things. One, we have to be defining the problem, so we know what we really want from the outcome, right? So you need to be coming up with boundary conditions. So that's a system boundary, we call it. And then how many stages? So is it cradle to gate or cradle to cradle? So if you are looking at a material that's just being placed versus a material that can be reused after the entire design life, that's what we should be looking at. And the analysis period. So how many years will this product last long? It could be 30 years, 20 years, it could be just 2 years. Depends, right? It depends on the product. So I'm just presenting to you a very generic aspect of LCA, okay? And the second thing is the inventory. So that's something very important. All of us have to be very familiar. I told you in the beginning also, you need to be creating databases that could be used by others. And that should be open source. If that is successful, I think others can actually provide you good ideas, and you can also benefit from that. And you can also be producing new products, new solutions that could be used by others, right? So you need to be coming up with the inventory. So you need to be having that database, data bank, where you can probably have primary from where you have done at your own lab, or you could be collecting from secondary sources, right? Which are literature, obviously, repositories. Then the thing is very important here is the assessment. So how do you, so is there a process to it? Yeah, so it all goes back to the fundamental principles, science, right? So we need to be translating this, whatever we have collected, into meaningful indicators, or what we call the assessors. So we need to be having the assessors, or what we have the metrics, performance metrics, right? And finally, we come up with the decision-making tools. So, which also includes the uncertainty and randomness. So if you're able to do that, you have a statistically robust product. So what we did before that, okay, so if you look at this, there are several standards for the LCA. I'm not going to talk about this because these are all out there. There are a few open sources. There are a few that you'll have to purchase. Obviously, they're all really expensive, obviously, right? So what we thought we should do is to come up with our own toolkit, automate that, so you're able to predict the assessment, right? So if you look at what this slide talks about, definitely because of the urbanization, what's happening, you're adding more infrastructure, which is a good thing, definitely, because you're able to provide facilities for several people. Now, one of the things out of this infrastructure is the pavements, roads, and that's part of the civil infrastructure. And what we are trying to do there is we are creating pavements, but then one of the things that is happening is to be creating those impermeable fabrics. So you're clogging the groundwater, which means if there is a precipitation, it simply does not go down, but there is a lot of runoff, which is why we say here that there are two important impacts due to urbanization, especially with pavement fabric, which constitutes approximately 30 to 50% or 20 to 40% of the entire urban area. If you look at the urban cities, 20 to 40%, in a dense area, it could be even more. Okay, and there are two important impacts. One is the urban hydrological aspect, where what we are seeing is we will see that there will be a lot of runoff, not be too much of percolation. We would like to have groundwater recharge, but then there is a lot of runoff going. Then the other thing is because of the concrete that's being placed around the city, there is that temperature differential between the urban and the rural setup. And that we call the urban heat island phenomenon, okay, UHI. And these are two important research areas for those who are taking up this as research. Please make sure that you probably target some of the things that are really in dire need, right? Okay, so what we would like to create are those pavement systems that can not only improve quality of life, but also making sure that we have good sustainable urban habitation, right? So pervious concrete, I'm not going to go into details of this, but just to familiarize for you. So pervious concrete is basically a specialty concrete, which has similar to conventional concrete aggregates in different sizes. But one thing here is it is a very special material because it has interconnected pore structure. Now, if you look at what we are saying here, it has limited or in fact no fines at all. So it's basically larger sized aggregates, which creates more porosity, or what we call void ratio. So that 15% or 20% or 30% sometimes porosity is what is the characteristic feature of this pervious concrete. And because of its high porosity, it also has low strength, which means it can only be used in low to medium volume roads at this point of time. Right? So if you look at this, there are two different pictures that we are showing from the lab. Again, we have placed some test sections. And so because it has interconnected pore structure, if you look at the images that we have collected, okay, we have done some X-ray microtomography, we've done image processing. So we have scanned the images and we have found that the material can get clogged, obvious, because it has high porosity. There's a very high chance that it will get clogged as well. But literature very clearly indicates that it can only get clogged top layer. How much thickness? Probably 1 inch. Okay, about 25-30 millimeter. Okay. Now, this is what we can, where we can use the product, low to medium volume roads, for example, parking lot or walkways and medians and many other applications. Okay, one thing that we did as part of demonstration is to have a parking lot with pervious concrete on campus IIT Tirupati. Okay, if you happen to come, please visit us. We will show you our sections. What we did there, we embedded some pipes beneath the layers, and we were able to harness water. Okay, so it's a published document if you want to read about that. So here is the picture where we had 5 meter width and 15 centimeter thick section. Okay, and this is the final product. I'm not going to in the details of these. The aim of this is to show you the LCA toolkit that we have developed, right? So here is the final product, and it's being used now as parking lot. Okay, so what we did, we wanted to understand how much of emissions, how much of embodied energy within the product, and then compare that with the standard product that we have in the industry and in the real field scenario, which is the conventional concrete. Right? So what we thought, okay, let's now come back and then calculate the embodied energy and also the kg CO2 equivalent. So we created a toolkit. It's an automated toolkit, okay, and goes back to the fundamental principles. That's what I told you. So you can actually go to the open source software tools, or you can probably get to the mode of purchasing a software, KLC software that can help you calculate all of these. But what we thought, okay, we should come up with our own toolkit, because there was no other toolkit for the pervious concrete. Thought we should do that. And so the idea here was to calculate these and also calculate the cost, capital cost that is required to place these sections, right? And we adopted what we call the cradle to gate. When we say cradle to gate, I told you this, that there are 2 or 3 or maybe even more cradle to gate or cradle to cradle approach. But what we used here was a cradle to gate because we didn't have the end of life for this material, right? We don't know what happens after 8 or 10 years of service. So we approached this cradle to gate. Again, if you have more scope, please go ahead. Cradle to cradle is probably much more robust than this, because you know the end of life and then you should be able to reuse it also, right? So here we developed a systematic user-friendly toolkit, and we assess the environmental credibility of these special materials. And it's a published document. So if you go here to this journal, you should be able to get this paper, read more about it. So what we did here, you see here, so we had this in situ versus the RMC. That is what we would like to, we were trying to compare. And again, compare 2 different materials. One is a pervious concrete, and then the other is the conventional concrete, with 2 different processes that we can create this technology, right? So you can see in the slide, one thing we wanted to have extensive amount of data that could be used to create those equations and also calculate. So we had our construction agency, the contractor, help us with the data. Okay, so the primary thing that we had was the construction agency itself. So we had the contractor help us with the data, raw materials, and then the pervious concrete, and then how much of water did they use, what was the water cement ratio, and all those things that we got from them. The other things that probably we didn't have was the global warming potential, right? And the embodied energy for some of the things that probably we never could get it from the primary source. So Central Pollution Control Board was one of them. Okay, that is secondary source. And then the material, for example, the ordinary Portland cement that we had, the 53 grade, and then the crushed aggregates, which is the I told you there are different kinds of aggregates that we used, and also it had a range. Now, the other thing that was important was the target compressive strength. So we targeted an M25, and we were able to achieve that also. So the range of values that was achieved in the field was anywhere between 10 and 25 megapascal. The real field sections I'm talking about. Okay, so we kept this as the target for our calculations. And here you can see there are 4 different scenarios that we were looking at. And I told you we were comparing 2 different mixing methods and 2 different materials, right? So what we did, so we came up with this toolkit wherein we were able to calculate the energy, the outcome, right? GHG, I told you, embodied energy, kg CO2, and also the capital cost. But then one thing that is input when you prepare these mixes, right, mixing phase, is the energy that is required to create the product. So I'll not go into details of this because this is the inventory, right? You can go through the things later. Now, this is the final model, and you see we created this in Excel itself, MS Excel platform, right? It's not very sophisticated. You should be able to get this done for your product as well. Okay, so here is the equation, and here are different variables that we were looking at. So if you look at this, one thing that we should be definitely familiar when you talk about the roadway system is the width of the road, how many lanes, how much is the width of the lane, right? And then the thickness of the layers. If it is a multi-layered system, thickness of different layers, right? And then material properties, so density, and then the production value. Again, these are the values that we either got it from the agency or from the secondary data source. So all of these we got from various sources, and then finally we arrived at these simple equations, okay, automated now, right? And if you actually see all of these are very generic in nature. You should be able to use it for any product of your choice now. That's why I told you in the beginning, right? This kind of a study that we did was probably aimed at looking at many other building materials as well, right? So here are some of the things that you might want to look at it later. Okay, we also wanted to have the energy consumed calculated, emissions generated, and many other things. You can look at this, all of them are here. Okay, now looking at the results. Now, if you want to interpret the results that we had, so two important things here. One is the embodied energy. Okay, look at this. This is the orange, or whatever color that you call it, right? For different scenarios, if you recall, go back for a minute. Okay, A and B are RMC, ready mix concrete. C and D are the in situ. It was done on site. Okay, and again, A and C are pervious concrete. B and D are the PCC. Okay, just remember that for a second, and then we will now start to distinguish between the various materials. So if you look at this, A and C, right? So they are the pervious concrete for you. So if you look at this, we are basically seeing about 50,000 units here, 50,000 megajoule per kilometer. That's the difference you see, right? Between the two different products. One is the pervious concrete, the other is the conventional concrete. So you actually have seen now from this particular plot that you can interpret the embodied energy, because due to pervious concrete is 50,000 less than the conventional concrete. And it goes back to what we were saying, that the product is sustainable, right? So you're now, you see, once you get the assessors, you should be able to analyze and then interpret what we wanted to achieve. So your hypothesis is already there. So you're now either accepting or rejecting the hypothesis, right? And again, if you look at RMC versus in situ, this versus this, you can see there is a difference, right? And again, coming to the GHG emissions, similar story here. It says only 6 units, but you see here it's about 6,000 kg CO2, a substantial number between pervious concrete and the cement concrete. And all of these are automated now, you see. That's what I'm trying to say. So the toolkit is there for you, ready-made. So you should be able to use this and then start interpreting between different products. And within the same product, you should be able to have distinguishing character between two different mixes and many other things that could be done here, right? So approximately 3 to 4% difference between the different scenarios there, so, right? Pervious concrete versus cement concrete there. Now, coming to sensitivity, because some of the things that we should be really doing along with the automated toolkit, within the toolkit also what you should be doing is to come up with the sensitivity. So which factor is more important than the other? That's something that is very important, right? And we actually wanted to look at the transportation distance, material production, mixing, compaction, and density. So you are looking at the entire phase, cradle to gate. Now you can extend this again, cradle to cradle. If you have the salvage, you can also include that for sensitivity, right? And you see here, the interpretations are already shown to you, right? So one of the things that people have always questioned is the density an important aspect? If you look at this density there, right? And what we saw that, no, it's probably not really important. It's the material that we look at, right? Okay, then the other important aspect I told you, apart from the embodied energy and the emissions, we also looked at the capital cost. So we came back again with the same toolkit. We created this, and you should be able to calculate the total cost that you will be incurring to place this material. Now, please understand, this is much different than the life cycle cost. Okay, this is just a life cycle analysis that was done for the others, but this is the capital cost that we incur during production and placement, right? So you see again the different parameters that are there. You can still further this, you can modify this, okay? The computational tools can be modified, further refined based on your input, right? So finally, if you look at this again, A and B, RMC, C and D in situ, A and C pervious concrete, B and D cement concrete, right? I'm looking at whatever number I have times 1,000. rupees. So you should be able to save a lot of money due to RMC. That's what this says. And that goes by fact, right? So you're able to prove through your toolkit, yes, what is found in the actual market is correct through our own toolkit. And that's why I told you, you should be able to create your own toolkit using simple MS Excel also, or maybe even a simple tool other than this. Okay. So coming back to this again, so what we are trying to do with this toolkit is we're trying to extend this to LCCA. So please work on this, come up with the economic perspectives. Full life cycle cost analysis has to be done on that, right? And that's where the big data. So one of the things that we are working closely with other colleagues right now is to have mixtures, right? Target mixtures, and use the artificial neural network to calculate and then integrate that with our toolkit. So that's very much possible, right? So this is one thing that I thought I should share with you. The second thing that probably will be more interesting for all of you is the pavement asset management toolkit, right? And we have now automated all of them. We have about 5 modules that we have come up with, and let me share with you all of those, because that's something, as I told you in the beginning, it's the academia industry model that we're working with. And this toolkit can straight go to the roadway agency and can be used by them. Now, one of the things that all of us are familiar is the database management, right? If you are not able to clearly have a good database, it will not be, it's really difficult for others to use this. And one thing that you should understand is manual survey versus automated, right? So if you are doing surveying in the field and you have to do probably thousands of kilometers, it's laborious and time consuming, right? So if you have an automated system, probably that will help us not only to store data, but also reduces the amount of time. So it saves time. So it saves time, but also saves money on that. And you can simply sophisticate your toolkits with that money. So you're able to invest more on this. Now, one thing that, so let me just give you a background on pavement asset management. So definitely pavements deteriorate like us, they also age, right? And if you are not addressing those problems that occur during the entire design life, it could be cracking, pothole, rutting, shoving, corrugations, you name it, it's there on road, right? If you're not able to address those on time, not maintain, then probably what will happen? It'll deteriorate faster than expected. That is what you see here. So if you're looking at the present serviceability index concept, which also goes back to the reliability and the confidence with which you have designed the pavement section, you will see that material will start to deteriorate. And if you don't accord any maintenance in between, it could be preventive, corrective, minor rehabilitation, or any other aspect, will simply deteriorate faster. If you do something in between, it can come back to its position and it'll serve for a longer period of time, right? So you don't want to see a premature failure. Now, what is the advantage of these kinds of maintenance? You should be able to avoid this premature failure and also manage your assets and help assets to regain their positions and serve longer. Now, how do we manage these? You have something called the pavement asset management system. And that system is it's an automated computer toolkit. It's a computer toolkit that's there, okay, with most of the roadway agencies across the world. Most of them have that. What they're doing is to have the database. So they collect data every season. It could be every year. It could be every month. Depends on how much money we have invested on this management system. Pavement condition rating also is done along with that. So you basically collect all of these data along with construction history and the strength properties of the material, right? What you do, you bring those, put it into the database, and then start calculating the performance of the pavement section. For example, this, what you see here, right? You are able to predict the performance of the system with the enough information that you have coming from the survey. Now, it could be an automated survey using a van, a network service vehicle, survey vehicle, or you do a manual survey depending on how much money is there with the roadway agency. Bring in that, you create modules within the pavement asset management. What kinds of modules? We will share with you in just a few slides now. Okay. What you do, you finally predict the performance of these systems. Now, that will help two things. One, it will help us make decisions which of the sections are in dire need of maintenance. Number two, how much money has to be allocated for each of these sections. So what we call prioritization optimization technique, right? You prioritize which of the sections need maintenance, and then you basically come back and optimize the cost, so based on the budget, right? And then you say these sections, the top sections which will be requiring repair, that will be done first, and then the next set of sections, right? And those things have to be done automatically, because you see, each of the times that you go to the field to do the survey, you come back and add that data point. One of the things that we haven't done in India yet, at least many states have not done, is to have this kind of road management system database yet. Even if they have those, they have not automated and then are not capable of predicting the performance. So that's where our automation comes into picture, right, of these toolkits. So giving you a brief history of PMS, pavement asset management, it all started in 1950s. Asher road test that came up with the serviceability index concept, present serviceability index, which is basically the difference between the initial and the terminal serviceability indices. Okay, and then they came up with something called the pavement management systems for highways, and that's a systems engineering approach. What they did, they got the survey done, whole to part, right? So you do the survey, go to the field, get all the data, culminate that into a database, come back, you create a software toolkit that is automated, obviously, right? Software toolkit that can predict for you the performance of the system. Now, how robust is the system depends on how sophisticated you make the program, right? Okay, and then again, project level pavement asset management came into being from the network level to project level. So each project had its own management system. Obviously, good roads cost less for us, right? That's the statement that they came up with. New tech. Then the report came up. They had several workshops on PMS, and then they came up with the guidelines. Now we have asset management toolkits. So it's not just about construction. It's also about managing our assets. If you look at the Government of India initiatives also, we should be able to manage our assets, not just keep building, right? That's something important that we should look at. So if you look at the overall picture of the PMS and the objectives, right? One, definitely you collect data. It's a circular thing, you see. You collect data, which means performance data, right? You see today and then you collect every year for the next 10 to 12 years, or it could be 20 years, it could be seasonal, it could be monthly. You create that database and then you automate that. You should be able to detect distresses automatically. It's not go there every time you go there, and then you cannot do that for thousands of kilometers, right? You should be able to just get the images or videos through your automated van or a vehicle, come back to the office, and you should be able to detect distresses using tools, right? And then also the tool should be able to analyze. Finally, predict the performance. That also you should be able to do it using the tool. And then come up with the alternate rehabilitation strategies. Not only that, you should go one step further and then come up with the cost comparisons. That will help you prioritize and optimize what you would like to do. Finally, implementation. That's where the construction comes into picture, right? So this is the asset management and the construction. They both have to go hand in hand, right? So what other thing that is important in this asset management is you come up with the alternatives. So that also should be, your module should be able to do that for us. If you're able to give the roadway agency, go with this maintenance strategy because this is probably the most appropriate for this section, then you have succeeded in telling the agency or convincing the agency, yes, based on actual data, images, right? This is what we should be using, alternative A instead of alternative B, right? So now looking at this picture here, you should be able to come up with the acceptable limits also using your toolkit. Okay. Finally, you should be able to tell the user, okay, you just have to input this and we will give you the performance prediction. If you're able to do this much, that'd be great. So now when you look at the different vans that we have, right? I'm sorry, not the vans, just vehicles that we have. There are different kinds of vehicles across the world to do the condition survey. Okay, there are a few. Manual survey obviously is there with us. Most of us are familiar with this, but then there are automated vans. There are cameras embedded on the van, on the vehicle, below the vehicle to capture the profiles, right? They're all laser based sometimes, and then also image based, right? So you should be able to get familiarized if you go and Google those. Now, one of the things that is there in India and what we have been using, and now coming back to our own work, is the network survey vehicle that is there, okay, in India, and that was basically manufactured at in Australia. Because you can see that here ARRB, the sophistication of the toolkit that's there, which can collect data, not the performance prediction, obviously, that came from ARRB and Australian Road Research Board. Okay, and what is the specialty feature of this van? You see here there are 3 different cameras that are mounted on top of the vehicle, and then there are cameras mounted below the vehicle also that can capture the pavement profile. So we have data coming from AP state, Andhra Pradesh, almost 13 to 14 lakh data points. So they gave us this much data. So we are now closely working with them and then giving them the toolkit that we are developing. Okay, and you see here what are the things that they have done. They have basically captured all kinds of distresses. Okay, fatigue cracking, pothole, rutting, shoving, bleeding, many other things. How they're able to capture that? I told you, not just based on the manual survey, but also due to the automated one. So that is able to capture that. Now, one of the things, if you really want to understand what pavement asset management is all about, please go to one of the papers that we just published recently in Automation and Construction Journal. Okay, one of my students actually, she did this. She's now finishing up a PhD. And one thing that she also was successful is to create different modules within the pavement asset management, right? And there are about 3 or 4 things that I thought I should share with you. One thing is we were successful in detecting pothole, okay, using the artificial neural network there, and quantify the amount of material that is required to patch the pothole. Second thing is a very large scale study that we did using 3 different data sets across 3 continents, and I'll share with you that also. So we are able to predict several distresses at the same time. And we are able to predict real-time distresses if you use any vehicle for that matter, not just the NSV that I showed you. You should be able to go out in the field, capture the video, come back and use our toolkit. Automatically, it will detect for you all kinds of distresses, approximately 18 of them. The third thing that I thought I'll share with you is engineering criteria-based pavement condition rating. Okay, that's something important because, you know, most of us are familiar with manual. You go there, you take a paper and pen, you do that. It's good if you have probably, you know, 10, 15, 20 kilometers or maybe maximum 100, enough manpower. If you have to do a large network, let's say thousands of kilometers, 10,000 kilometers for a state, that's probably difficult. So you'll have to come back and then come up with an index, right? That's something important. Then we also came up with a road roughness prediction one. So you should be able to predict the roughness. That also goes back to the safety. So how safe is the road based on the roughness prediction, right? That also we were able to do using deep learning techniques. And then the final thing that I thought I'll share with you is homogeneous sectioning. You have 100 kilometers of roadway stretch. How do you segment those? Will you segment those 10 kilometers each, 10 of them, or 1 kilometer each, 100 of them? Depends, right? Depends on which of these sections are homogeneously distributed, which of them have similar distresses across. So first thing that I thought I'll share with you is the PDQMS, pothole detection, quantification, and management maintenance system. That is a published document. If you want to know more about it, please let me know. We will share with you. One thing you people are very familiar, all of us, right? Potholes, are definitely detrimental, and it can probably create accidents. I'm not saying probably, I'm just saying probably, because there are a few potholes that will not, but there are a few extreme ones that can definitely do that for you. So you should be able to predict the pothole, right, using images. That is what we should be able to do using automation. That is what is the first objective that we had. So we wanted to predict the pothole and also come up with the amount of material that is required to patch these potholes. So I'll not go into details of what pothole is, because all of us are familiar. So it's a published document there. So we created a framework using You Only Look Once. This is an open source software. Okay, it's a version 3. So what we did, we created an architecture based on images that we collected. Okay, it could be colored or grayscale, no problem. So what we did, we collected the data set, and then we created an architecture in the open source YOLO, and we segmented those potholes from the images. So you have an image, and you might have 3 or 4 potholes, but your toolkit should be able to automatically detect the bounding boxes, the boundaries, right? So we were able to do that, and then the quantification of the extent of pothole. So not only severity of the pothole, which means depths of the pothole, but also the extent of pothole, which means length and the width. Finally, come up with the quantification, right? So here is the slide that can give you more information. So what we had different depths of potholes. I told you just a while ago, right? And what we did, we classified those, and we labeled those into 3 different classes. So we had 9 different classes to start with, and then we came up with 3 important ones: low severity, medium severity, high severity. So these are the labeling. So our automatic network is able to not just able to detect the pothole, but also label the class. So that much we were successful. So you see here, so the procedure is as follows. So you have the original image coming from the roadway section. Okay, you can use an NSV to do this. So you go to the field, you capture this image, come back, pre-process it. Why pre-processing required? Because you need to convert those to the desired pixels, right? Okay, and then, yeah, so another way of looking at it, you have this image. You see here, this is the pothole. I don't know if you're able to see this. This is the one that I should be able to capture. You have to create that bounding limit, right? So we use a tensor quantity there. So it's a data dimensionality. So in the network architecture itself. And then we finally came up with the width and the length of the pothole along with the depth of the pothole. 3-dimensional, right? So here you see another way of looking at it. So we got this image from the database. Here is a pothole, you can see that. So put that into the architecture. So it basically takes up the image, and then there are different layers. What it does, it simply creates that bounding box around this pothole and labels it. If you see here, it says L, which basically means low severity pothole. Okay, if it were called M, it would be medium severity. H, high severity, right? So it's able to predict that using the architecture and the fundamental principles that we used. And finally, it simply gives us the bounding box and the pothole here. You see, that's what it gives. And then you should be able to calculate the amount of material that is required to patch this pothole. So here is what we did. These are the chronological steps that we followed to get into the pothole patching there. Okay, and then looking at the results, the statistical the parameters. How confident are we with our product? Look at this. The mean average precision is very high. In fact, 89% plus. It's slightly higher than the existing one. Okay, in literature. So we used about 41 images. Now we have probably gone even beyond that. I'm not going to share that with you because it's still not published. But we have trained, validated, and tested on 41 images. That's something that you should be familiar with. And you can see here, this is really very high, right? Okay. Now, what are the next thing that I thought I should share with you is the multi-distress detection system. And I told you this is a massive work that we did for the state. Now, we were able to detect 6 different types of distresses and 3 different severities, which means 6 times 3, 18. 18 different distress classes automatically, right? And what we did, we used YOLO version 4. It's again, it's an open source software. It's one step advanced than what we did for the pothole detection. That was version 3. This is version 4. We trained, validated on diverse data sets. Again, I'm going to share with you the different data sets that we used, and it was able to detect real-time videos also. So if you're using this toolkit, you run your video into the architecture, not just image, but also the video, you should be able to detect different distresses at very high computation rate. It's a published document now. It was presented in the Transportation Research Board meeting, and it's a published document in the Journal of Transportation Research Report. It was accepted. It's now getting published very soon, maybe in the next one or 2 months. Okay. So what we did, you see here, this is what I thought I should share with you. So there are 3 important things. One is the passenger side camera, front, and the driver. There is also one more, which I'm not able to show you here, is the one that is below the vehicle. Okay. So apart from these 3 that we got, videos and images, videograph we call it, right? We also got these information from the APRDC. Distress rating forms that we got, different distresses that they thought were there based on the survey of about 50-60,000 kilometers using the NSV, and the other indices, deflections and the trial pit studies and so forth. Okay. And 3 different data sets that we used. One was the long-term pavement performance database coming from the Federal Highway Administration. So there were about 50 to 100 images, okay, all the way collected from 2002 until 18. And then the other one is an open source, also German asphalt pavement distress dataset from Germany. Okay, about 4,000 plus images here. What we did is to have, and the other thing is our own APRDC images. The number of images was about 800. It was about 100,000 images, and the number of images that had pothole, the distresses, were about 800. Okay, so in total we had about 1,500 images to work with from a large pool of data set. What we did, we pre-processed all of these videos and images. Okay, we filtered those. We converted the colored ones to gray. We filtered those again. Okay, it could be video, it could be an image coming from the data set. Okay, it could be both of these. Whatever is the case, you first have to convert those to gray, pre-processing, that's what we call. Okay, and then we enhance the image for the network architecture read it. That's something important. So we worked with this 1,500 images, and this is what we got. So you see, this is the original image we had. We pre-processed it, original pre-processed. So you should be able to see visually what kinds of distresses are there on these sections, right? First step. Second step was to come back and integrate with label IMG tool, because I told you it's not just detection, but you should be able to label those, pinpoint and tell, okay, this is the distress, this is the extent and severity, correct? So we had 18 labels that we created. So we customized the architecture, and we were able to detect and put the bounding box around it and also label those. So I'll show you some of the things. So we had about 1,500 images. You can see here, this is the published document. Now we have gone further, and we actually have found, so this is a number that you might want to remember, we have close to 97% now based on additional images that we added in the last 6 months. Okay, and the average loss has actually come down much further. So loss is much lower now than 1.5. So the MAP is now more than 94%, 97%. Okay, so here you can see all the different kinds of statistics. Here is the picture that I thought you should probably see, is you are able to detect the distresses and also label them. So you see here, if it says round red color bounding box, it says patch deterioration medium severity. So it's able to detect and also label the image. So that is what we are able to do. And also the second important thing is if you have more than one distress in the same image, that is also possible with our architecture. Okay, and it's able to predict not only this, but also predict the statistical variability there. Now, the third thing I thought I should share with you is the distress engineering criteria indices, PCI, Pavement Condition Index. I told you, if you are not able to provide a range of deterioration, you will not be able to come up with the maintenance strategy, right? That's part of the pavement asset management. So you should be able to capture the type, extent, and severity of the distresses in any segment that you have, correct? Now, there is a procedure that is there in ASTM, American Society for Testing Materials, as a procedure, and that's well utilized for parking lots. But is it really compatible for Indian conditions? So we came up with our own criterion. We call it engineering based criterion. Okay, and we did it across 100 kilometers when I was at IIT Kharagpur. It's a published document in ASTM journal. Okay, we came up with this data sheet, went to the field, we did manual survey there. Okay, and we came up with at least 15 distresses for each of the segments. So we segmented those 100 kilometers into about 40 or 50 sections, and we came back and then rated those sections as well. What we did here, we came up with the rating based on deduct value curves, something like this. Okay, so that's what we did. And then finally, we came up with the engineering criteria for each of the distresses based on the deduct value. Okay, you can go there. And then we came up with this final outcome was the acceptable limit beyond or below which the pavement section is considered failed. Okay, so that is what we did using simple MS Excel toolkit. Fourth thing I thought I should share with you is a deep neural network based road roughness prediction model. Okay, what we did here was to have data coming from the long-term pavement performance database in the US, and we were able to predict the international roughness index with all of these parameters within our neural network. Okay, so it was a deep neural network that we used, and we were able to predict the roughness. So we have gone one step further. It was recently presented in a conference at IIT Bombay. Okay, and you can see here the mean square error, it's really low. Actually, it was 473 data points. Now we are expanding that. We have much better values now, much lower errors, I should say. Okay, and the last thing that I thought I should share with you is the homogeneous sectioning. This is something also automated now, and we have done it for entire state of AP. We are just showing to you maybe a couple road sections now on this in this presentation. So what we did, we went and looked at the literature. The existing literature says that we are able to predict only one parameter. It could be rutting or roughness. We said, okay, we will go ahead and predict one more with our network architecture, and we were successful, in fact. Okay, so we used these kinds of charts. So you should be familiar with, some of you might be familiar with the C charts. Okay, quality control charts, something familiar for some of you. What we did, we had database coming from AP for all the different districts, 13 districts, okay, and several different pavement types. I'm just showing to you one screenshot, okay, and what we did, we had long sections which we divided into homogeneous sections based on two important things. One, rutting, the other is the roughness. So far, people have either done rutting or roughness. They haven't done biparametric approach. So we were the first people to do that. And then you can see that we came up with the control limits with simple terminology called SPERN. Okay, that basically talks about both rut and roughness with respect to the means, corresponding means of those values, magnitudes. Okay, and we were able to segment those stretches based on that. So you can see it's really very good. The variance was good. It had very good R square as well. Final outcome of this study was to classify the pavement types into different segmentations, meaning based on the spurn value, I told you what spurn means. It depends on what kinds of values that we have, the rut depth versus the roughness value, right? And we came up with sections that were good, moderate, poor, and alarming, 4 different sections. And also came up with the indicative treatments for those kinds of distresses. If it was good, we just do the preventive maintenance. If it was excellent, nothing required, right? If it was 0 spurn value, then you don't have to do anything. If it's slightly greater than 0, then you'll have to do something to that, right? If it was much larger, then you have to go for a reconstruction. So we color coded those treatments and also the distresses. Finally, yeah, this is also a published document, in fact, recently presented. So finally, I thought I should share our expectations coming from the automation, right, of whatever that we have done so far. We have done advanced further, but I'll be able to share that after it has been published, right? So we would like to actually also have the automation in terms of prediction. So we are now just showing to you what we are able to capture as distresses, detect distresses, segment the sections. But what we would like to do also is to have performance predicted using the automated toolkit. And we are now in the process of doing it. And I'll be able to share that with you maybe in future presentations. And one thing that we showed to you was the LCA, life cycle assessment. But one thing that you should be able to do, advance yourself, is the life cycle cost. Consider the entire life cycle and also compare not just the initial cost, right? You should be able to compare the life cycle cost, which means you should be able to get the entire data. You should have entire data of the service life. Only then you will be able to do it. Otherwise, it's difficult. Okay, and then one thing I really want to urge all of you is to please get in touch with the academy, with the industry, if you're an academician. And if you are from industry, please get in touch with academic partners. Let's work closely. I think it should be a mutual thing. Only then I think we should be able to have better roads in the country. And it has to be a long-term performance goal. That's what we should be able to do. And most of the countries have done this. And we have enough resources and manpower. I think we should be able to do it as well. And one thing is the retrofitting and econometrics. We are now coming up with those topics also. We'll be able to share that in the future on these. And finally, for those academicians who are very fond of being in the lab, you should also go to the field, come back with correlations between the lab and the field, right? So that's the end of my presentation. And I would be remiss if I don't acknowledge my colleagues and the large group that we have, the student group, which has been helping us, and the industry, right? Industry personnel. So that's it. I have Sujit.
Sir.
Thank you.
Sir. Thank you, sir, for giving a nice presentation. Also, it is a very challenging topic in transportation sector.
That's
actually, I have no idea, but actually, I have my specialty is transportation. But regarding automation in pavement, actually, I have zero knowledge. Actually, from your slides, I think participant also gain some knowledge about automation in transportation sector. Sir, some questions actually they have asked actually.
Sure.
Sir, you have told in one of your slide, biparametric based homogeneous section. Sir, you have considered rotting and roughness.
Correct.
Can we consider fatigue?
Yeah, that is what I told you. We have now considered 2, and it is definitely extendable to many more. So the literature was saying only 1, so we extended it to 2, and definitely we should be able to extend it to further others. Again, you need to have data for that.
Oh, okay. Sir, in case of pothole repairs, actually, in case of flexible pavement, it's okay. But in case of rigid pavement, if there is any depression or pothole-like structure, can automation, by applying automation, can we repair as per standard quality? in case of rigid pavement, actually.
Yeah, we haven't tried that, but that's a good question. We have only been targeting asphalt, flexible pavement side,
Sir,
but I think future research should target rigid also. Definitely, we should, because the architecture is there. So if you're able to detect a distress, it should be expandable. Definitely.
Because now NHI is targeting
Correct.
cement concrete roads all over India, so
Correct,
that
correct.
is required. That's required. Sir, another thing. Sir, another thing. Pothole repair by using automation, it's okay, but edge. How to repair actually edge of the pavement actually? Because that is required any side forms. How to repair actually that?
If you're
Edge of the pavement.
yeah. So that's part of the asset management anyway, right? You should be able to predict. So that I've not shown you this in this presentation. The prediction model that is coming up. We haven't published that, but next time maybe we will be able to share more details. If you're able to predict the performance, you should be able to also repair. So retrofitting, repair, econometrics, that's all the next future scope. We haven't shown you that yet.
Sir, another thing. In pervious concrete, you have told clogging will be occur. If oil is inserted into that, different vehicular oil. So how to repair actually that things? But in a post stand or any NH, oil is leaking from the
oil leakage is there. That's a good question. Right now, we are not using pervious concrete on highways.
No, sorry. In case of the bus stop, because
Bus stop,
oil leaking is there, sir, more.
That's there. Correct.
If we are using that in that part, then it will create problem. Then how?
We have to check for the chemical properties. We haven't done that yet. That's another good scope. In fact, leachate is another thing that we haven't done. The chemical attacks. There is literature. If people are interested, they should go to literature and see what chemical tests they have done on pervious concrete. Because you see, it's still chemistry, right? Sure. So the chemistry of cement, chemistry of aggregate interaction with cement, it's similar, except that we need to do more work to check for that.
Sir, pervious concrete can in future, as it is in your scope of research, that will use that pervious concrete into NH in your research?
Yeah, we are good question. We are coming up with new products for highways within the next 3 months. That's all I can say at this point of time. I cannot divulge more details. Yeah.
Okay.
We are coming up with highway.
Okay. Sir, good, sir. Sir, another request from participants actually. They are requesting you to give another lecture for coming 3 days actually. If another lecture they are expecting from you in 17 or 18 or 19, they are requesting. If you are free, then it's okay, sir. Otherwise, no problem.
Yeah, I'll have to check my schedule because I have an international meeting tomorrow and day after.
Sir, actually, our course will be in 19. It will be 17, 18, and 19. If within that 3 days, if you will be free for first half, then it will be okay, sir. No problem, sir.
Let me check my schedule.
Yes, sir. Please check. And then send me, sir. So, sir, thank you. Thank you
once
again.
Thank you so much. And again, special thanks to your team, entire team, and hope this this program will go successful. Workshop will go very successful, and the audience will get benefited.
Thank you, sir.
I just want to tell one more thing. Just get encouraged to do good work. We have enough resources in the country.
Exactly.
Make use of it. Harness the energy. Do good work. Do a lot of good work in the lab. Bring it to the field.
Exactly, sir. Because only we are concentrating about laboratory works only.
Correct.
But we are not implementing in field.
Yes.
So we will try. Also, we expect the engineers, those who are participating.
Sure.
They will also try in the field, sir.
So you can always call me if there is any question. The participants can call me, can email me. We have done a lot of test sections also, and we are doing it for NH. NHA project is ongoing, so we are right now working with 2 different NH units. One Tirupati, Chennai,
Okay,
The
sir.
other one is Renugunta, Naidupeta. Both of them
Okay.
together, it's about 130 plus about 200 kilometers. So we have 200 kilometers of roadway stretch that we are going to instrument and have test sections built.
Okay, sir. Very good, sir.
Yeah, so-
It's a very nice approach, actually, sir.
Yeah, yeah.
Okay, sir. Thank you, sir.
Okay, thank you
Thank
very
you.
much.
Thank you, sir. Okay, sir.